Welcome back, fourth grade. Today we're going to be filling out 2 notebook pages, so write the next 2 page numbers in your table of contents. Today we are studying Module 3, Lesson 23, the Associative Property. Take a moment to pause this video, write in your table of contents, and then let's move on to our lesson today. Our objective today is that we can use the associative property to find factors of a number. There's 2 really key vocabulary terms we're going to be using today, and if you don't understand those words, you'll have a hard time understanding the entire lesson. Those vocabulary terms are, of course, the associative property and factors. So let's review those vocabulary over here. A factor is a number that can multiply into a product, an answer to a multiplication sentence. For example, 3 and 2 are factors of 6 because 3 and 2 are both examples of numbers that can multiply into a product, which is 6. The associative property has to do with factors. The associative property means it doesn't matter how we group the factors. They will still multiply into the same product. So what does that look like? What does it mean to group factors? Well, let's look at 2 examples down here. We're going to look at the number sentence 12 is the product of 6 times 2. And the multiplication sentence 36 is the product of mystery number times 4. Let's start with the number sentence that has more information. 6 times 2 equals 12. If I were to further break down 6 into its factors, what would it look like to multiply 2 by another number to get 6? Well, 2 times 3 equals 6. And we would get the same product, which is 12. We're not changing any of our numbers. This is still 6. We're just breaking it down into its factors. So let's group our factors differently. What if instead of having the parentheses around 3 times 2, the parentheses went around 2 times 2, and the 3 was left on its own? Would we still get the answer 12? I know as a mathematician that I do whatever is in the parentheses first. So over here, I was solving 6 times 2 because I solved 3 times 2 first and then multiplied that by 2 to get 12. This time, I'm going to solve 2 times 2 first. 2 times 2 is 4. 4 times 3 is still 12. Even though we grouped the factors differently, we still got the same product. 3 times 4, which equals 12, and each time we solved, our answer was 12. Let's try it again, but with less information this time. 36 equals blank times 4. If I skip count by 4s, how long will it take for me to get to 36? What math fact do I know blank times 4 equals 36? 4, 8, 12, 16, 20, 24, 28, 32, 36. That took 9 groups of 4. So let's break down 9 into a factor pair. We have blank times 3 to represent 9. What times 3 equals 9? I know, to finish that math fact, it's 3. So we're asking ourselves, can this still equal 36? Since 3 times 3 is still 9, and we know 9 times 4 equals 36, then yeah, the second number sentence still equals 36. Let's test out the associative property in the next line. If we grouped our factors differently, if we put the parentheses around 3 times 4 instead of 3 times 3, would we still get 36 as our answer? Well, let's bring down this number 3. And let's solve what's in our parentheses first. 3 times 4 equals 12. 12 times 3, I can't have 12, 24, 36. It is still 36. The associative property works. We grouped the factors differently and we still got the same answer. 3 times 12 equals 36 because 3 times 12 is equivalent to 36. So now that we have a better understanding of what the associative property is, now that we've seen it in action and understand that how we group numbers doesn't affect our product, why would we learn the associative property? The associative property is really helpful for us when we have trouble generating our math facts. Let's say, for example, you're asked this question. Is 2 a factor of 32? Well, I don't usually count by 2s to get to 32. I normally stop maybe around 20, maybe 24. So I don't know that math fact by heart. But because of the associative property, and knowing it doesn't matter how I group my factors, let's think of another math fact that multiplies into 32 and see if we can trace down the number 2 in that math fact, just like we were able to pull a 3 times 3 out of 9 to find out that it still equals 36. So instead of skip counting by 2s, I'm going to do a math fact that I know equals 32, which is 8 times 4. So I'm going to pull an 8 and a 4 out of 32. Can I pull 2 out as a factor of 8 and 4? Well, let's see if I can multiply anything by 2 to get to 8. 2, 4, 6, 8. Takes me 4 groups of 2 to get to 8. Can I do the same thing for 4? 2, 4. Oh, only 2 groups. So what I'm noticing is that because 8 is a factor of 32 and 2 is a factor of 8, and it doesn't matter how I group my factors, I'll still get the same product. That means that 2 is also a factor of 32. Same goes for the number 4. Because I know 4 is a factor of 32 and 2 is a factor of 4, and it doesn't matter how I group my factors because I'll get the same product, that definitely means that 2 is a factor of 32. Let's generate some more factors. Is 3 a factor of 72? I definitely don't skip count by 3s until I get to 72. I usually stop at 30, maybe 36. So instead of skip counting by 3s, I'm going to use a math fact that I know equals 72. A factor pair that I know multiplies together for a product of 72, and that's 8 times 9. Can I pull the factor 3 out of 8 or 9? If I skip count by 3s, I'm going to count my 3s like a champion. I'm talking 3, 6, 9. I can't get to 8. That's not a number I can skip count to, but I can skip count to 9. 3 is a factor of 9 because 3 times 3 equals 9. Because of the associative property, I know it doesn't matter how I group my factors, I'll still end up with the same product. So if 9 is a product of 72 and if 9 is a factor of 72 and 3 is a factor of 9, then that must mean that 3 is also a factor of 72. In this next problem, I'm going to have you keep building down your web. And we're asking, is 6 a factor of 96? When I skip count by 6s, I don't typically go all the way to 96. I'll stop at 60, maybe 66, maybe 72 if I'm counting by 12s, but I never make it as far as 96. So instead of trying to skip count by 6s, let's use a math fact, a factor pair that we know makes 96. And I know 8 times 12 equals 96. So in my web, I started with 96, and I broke down the factor pair 8 by 12. Let's keep building this web. Remember, we're starting with the number 6. We're asking, is 6 a factor? So let's continue down the web. If I skip count by 6s, will I get to 8? No. 6 is not a factor of 8. If I skip count by 6s, will I get to 12? 6, 12. I can. 6 is a factor of 12. So let's keep building our web with the math fact. 6 times 2, which equals 12. Because of the associative property, I know that it doesn't matter how I group my factors. So if 12 is a factor of 96 and 6 is a factor of 12, that means that 6 is also a factor of 96. For this last problem, I have a question for you. What if we stretched our factors out more than once? Meaning we built down further in our web. Does the associative property still work? So let's use a large number. Is 5 a factor of 200? I certainly do not skip count by 5s until I get to 200. So a factor pair that I know makes 200 would be 100 and 2. I know that I can't find 5 in the number 2. If I skip count by 5s, I'm already long past this number since 5 is greater than 2. My best hope to find the factor 5 is by going down the route of using my 100. A math fact that I know goes into 100. Again, I'm trying to locate a 5, but I don't typically count by 5s to get to a 100. A math fact that I know does equal 100 is 10 times 10. Can I break those 10s down further until I get a factor of 5? Well, I certainly can, because I know that 5 times 2 equals 10. Same for this 10. 5 times 2 again equals 10. According to the associative property, it doesn't matter how I group my factors. If 100 is a factor of 200 and 10 is a factor of 100, then that means 10 is also a factor of 200. And that means that if 10 is a factor of 200 and 5 is a factor of 10, that they all connect together to be a factor of 200. Yes, 5 is a factor of 200. So why is this important? If you ever get approached with a math fact that you don't understand, like 5 times what equals 200, you can best use your associative